Hello, my dear friends. I am Dr. D.D. Sawant from J.A.T Science and Commerce College for Women, Malegaon Dist-Nashik. The topic which to be discussed is that a theory of isostacy. As the concept of isostacy is based on the principle of buoyancy, first outlined by Archimedes. Buoyancy is the ability of an object to float in a fluid by displacing a volume of that fluid in mass to the floating object's own mass. A steel ship floats because its shape displaces a volume of water equal to its own weight plus the weight of its cargo. Thus, an empty container ship displaces a smaller volume of water than the same ship when fully loaded. The water supporting the ship is not strong in mechanical sense, and hence the water does not support a ship in the way a strong steel bridge supports the weight of your car. So, any region of the continent that projects above sea level is supported in the same way. So, the any region of the continent that projects above sea level, consider the continents again containing Mount Everest, the highest of the earth, mountain at 8.84 km, means the 29,008 feet above sea level. Mount Everest and its neighboring peaks are not supported by the mechanical strength of material within the earth. Nothing on our world is that strong. Mountainous upper surface of the continent floats high above sea level because the lithosphere of which it is part sinks into the plastic asthenosphere until it has displaced a volume of asthenosphere equal in mass to its own mass. So, as it is based illustrated by a high mountain chain which rises above the surface of the earth but has to be compensated by deep roots of sialic material which penetrates deeply into the underlying sima. Isostacy occurs because the crust is by the more dense mantle beneath it, and each portion of the crust displaces the mantle according to its thickness and density. So, the denser crustal material sinks deeper into the mantle and hence less dense crustal material. Alternately, thicker and crustal material will extend to greater depth than this crust of the same density. So, as a result of isostatic adjustment, high mountains and plateaus have a great vertical thickness, sink deeper into the mantle than do areas of low elevation, and any thickness change in area of the crust, such as the removal of material by erosion or the addition of material by sedimentation, volcanic extrusion, or accumulation of large continental glaciers cause an isostatic adjustment. So, the concept of isostacy, therefore, is fundamental to studies of the crust major features, which are continents, ocean basins, and mountain ranges. And to understanding the responsible of crust to erosion, sedimentation, glaciation, and tectonic system. The continental glaciers are a clear example of isostatic adjustment of the crust. The weight of an ice sheet several thousand meters thick disrupts the crustal balance and depresses the crust beneath. In both Antarctica and Greenland, the weight of the ice has depressed the central part of the land masses below sea level. So, the Antarctica provides an excellent example of how continents maintain isostatic equilibrium in the face of changing conditions. Most of the southern continent is covered by a layer of ice as much as 4 km, means 13,000 feet thick. The great weight of the ice has pushed much of the continental crust below sea level. If this ice were to melt, Antarctica would slowly rise from the water much the same way a ship rises while being unloaded. So the construction of Bakra Dam is another example of isostatic adjustment because the added weight of water and sediment in the Gobind Sagar as a reservoir was sufficient to cause measurable subsidence. So, in brief, the concept of isostacy depends upon the model of the earth crust, in which lighter continental masses float on a denser substratum. In the words of Steers in 1961, the doctrine of isostacy states that whenever equilibrium exists on the Earth's surface, equal mass must underlie equal surface area. So, the concept of isostacy has been conceived differently by different geologists. The view of a few of them are discussed in the following. That Aries views one of the view which will discusses as the astronomer Royal in 1851 opined that the continents which are made of lighter material Cial are floating over the substratum which is made up of denser material called as a Sima. In fact, the isostacy is really nothing else than that of the ordinary flotation, and the examples of iceberg floating in water may help stress the fundamental concept of the doctrine. Ice floats in water in such a way that approximately for every 1 part above water level, there are 9 parts below. So, in other words, the density of the rocks must be relatively low down to considerable depths below these mountains. The important points, however, is that they are compensated as a whole and the individual peaks and valleys are not separated compensated. To take a somewhat far-fetched examples, it would be quite wrong to assume that if Mount Everest is about 3000 feet high and if the ratio assumed of drought to freeboard are correct, then there is a downward projection of lighter material beneath that mountain reaches to about 240,000 feet. By stating of mountain areas being compensated, it is implied that the mountains are regarded as a great plateau whose height is equal to that of a mean height of the mountains chain. So the compression to be known that this is the type of stress that squeezes and shortens a body of rock, and compressions occur at or near convergent boundaries. So by stating of mountain areas being compensated, it is implied that the mountains are regarded as a great plateau whose height is equal to that of the mean height of the mountain chain. So Airy established his point with the help of an illustration of wooden blocks of different heights floating in water with each block moving vertically and individually, independently of its neighbor. So all blocks are of equal density but different heights, and they float, the longest blocks extending deepest into the mantle. So at a certain depth equal to or greater than the thicker crust, the pressure is everywhere constant, and below it is the mantle is in a state of hydrostatic equilibrium. The blocks emerge by amounts which are proportional to their height, so that the block which rises highest above the water is also a block which goes deepest into the water, and hence these blocks are said to be in a state of hydrostatic balance or equilibrium. Similarly, the land masses are composed of similar density of rocks, but they penetrate deep into the substratum in proportion of their height. So thank you very much for listening.